Very good afternoon to fellow lecturers, friends, and members of the floor. My name is Eden Woon, and with much guidance from my supervisor, Dr. Ilham Maran, this presentation would be to understand the challenges that wind energy harvesting presents and ultimately answer the question, can we utilize wind energy in Malaysia? Let's start things off with this quote. We need to be meticulous and attentive in order to better climate change. Regardless of how rich one may be, nobody's going to buy their way out of the destruction of our own planet. The order for this presentation is as follows. Due to the nature of this research, I will be entering the methodology first before literature review. Alright, let's begin. What is renewable energy, wind energy, and how do we use it? Renewable energy is defined as a source that gets replenished faster than we can consume. Fundamentally, all energy comes from the sun, and for us to really utilize this, there must be some conversion happening to induce this electricity. That's where Faraday's law of induction comes in. What about wind energy? As the name suggests, this energy stems from moving fluid, wind, which is basically just fluctuating air pressure due to temperature difference. Though highly chaotic, its kinetic energy may be harvested by feeding it directly into a wind turbine. Engineers from around the world has come up and agreed on this formula for power in wind. As it suggests, airspeed is key as it is cubed in this formula. This means that a slight change in speed dramatically affects the power generated from each turbine. So how do we harvest wind energy? What we normally see and visualize when talking about wind turbine are horizontal wind turbines, and is named as such due to its rotation in parallel to airstream. Generally, it requires a turning mechanism or yaw control to constantly face the wind. This is generally used for higher wind speed and it is tall and more structurally sound. On the opposite end, we have the vertical turbine, which works in perpendicular to the airflow in all directions and favorable in low speed regions. Proceeding into the actual research, I would like to present how it is done. The methodology for this research comprises of three parts. The first one being the literature review with all the articles. The second will be wind speed data collection from two sources, Global Wind Atlas and the Malaysian Meteorological Department, and power simulation from Simulink. This model and other details may be found in the report. The main focus for this research will be on the horizontal axis wind turbine. So, to the main point of this research. The numerous challenges found in wind speed energy sector may be broken down into these categories, from the planning to the people and ending with challenges that the technology do bring. This is the cost breakdown for just a single wind turbine. Just 6 million ringgit in 2006, and if you consider inflation, 8.22 million ringgit, with the NASA and electrical connection contributing the most of the cost. But what about offshore wind turbines? In terms of cost, it is obviously more expensive. It is almost 3 times the price, but considering how far it is from land, the wind speed is higher, though maintenance will be much harder. Now, because of how wind energy harvesting is new and unpredictable, programs and trade agreements are a must to boost this sector. The lack of proper supply chains will cause companies to take shortcuts or face hardships of procuring materials or even just avoid wind energy harvesting at all. Think about it. I don't think I can finish my research in time without support at all. Following that, we may always think that wind turbines are entirely green. That may be true when it's running, but for that to happen, some pollution will occur nonetheless, and this presents itself during manufacturing, transportation, and operation. One example would be the emission of cement particles during the manufacturing process. Under skills availability, wind energy sector requires skilled workers. Getting engineers alone is not enough as many roles such as developers and analysts are needed to run the show. But those who are qualified will ask the same question as all of us. Is it worth to work in the established field or take a risk in developing the new wind energy sector? No one really wants to dedicate their time towards something unstable, and in some sense, we may consider this as a sacrifice as well, just like the Wright brothers towards the avian field. Now, on that note, Some parts of the world lack the training necessary due to how new and unreliable wind energy is now. Let me ask you, how much of these points did you learn in SPM? And how much of these points are they learning now? If we do not specialize in this field, we do not have the knowledge to push this sector forward. In China, it was also revealed that they are reluctant to conduct virtual training. It is done strictly physical. This leads to students becoming afraid of the industry. They do not have the technical skills, as they don't all have equal access, and they may pick up another unwanted skills, reluctant to work flexibly. In another section, the lack of clear policy may confuse companies as they are not sure on how to dispose these turbines once their life is over. Does it go into the landfill? Does it get recycled? Perhaps it is repurposed. We do not know. Even unclear policy makes pre-existing contract difficult as their pathway becomes very, very vague. In the face of uncertainties, investor will obviously stay away until it is well established. This is clearer in the United States, where more focus lies on fossil fuel than renewable wind energy. An example would be the PTC, where extension was supposed to be 4 years is now made into 1 year, which is very confusing for the R&D department. Again, wind is chaotic and thus unpredictable. In India, their power plants are forced to work at a lower efficiency to avoid damages, as the wind might suddenly spike or dip when it feels like it. Let's talk about urban areas. Sure, there's high-rise buildings, moving cars, wind tunnels, but these are useless. Building on ground is stabler, and wind tunnels are useless if they are everywhere. The roughness in urban areas are considered to be level 5, which is basically just a wall in front of you. This breaks the winds and slow it down. Okay, let's take way out then. Let's put it on water. This leads to a whole new problem, the buildup of salt that damages and cripples wind turbine component. Like I mentioned before, maintenance is hell on offshore turbines, and with this kind of damage, it is just not worth it. Onto some more interesting category, wind turbines are known to cause harm to wildlife, especially avian animals. However, in comparison to deforestation, these are just as rare as lightning striking twice in the same spot. Underwater though, turbines generate vibration, which seems like nothing to us, but given how waves propagate in water, marine animals are basically punching bags. We humans also have problems with wind turbines. In some study, constant low-frequency sound may cause psychological damage in the form of sleep disorders and other long-term illnesses. Like the video shown below, wind turbine produces shadow which may be dangerous for epilepsy sufferers. Not to mention the opposite of it, the reflection from the blades may blind people. Wind turbines do not work wirelessly. Wires and thus electric poles are needed to transmit this power, and these may be unsightly. Take for example this picture of Kuba National Park. To you it looks nice, but what happens if we put wind turbines on top? Also, some papers suggest that it affects radar equipment on aircraft as well. Under Malaysia context, all papers agree that hydro is the best renewable energy source, with one paper showing an efficiency score of 0.686, whereas wind energy has an efficiency score of 0.001, a negligible value. Also in agreement would be the low wind speed across Malaysia. Even though it was quite high during the northeast monsoon, the data indicates otherwise, which will be presented in more detail later. The support from government seems to be lacking when the Renewable Energy Act 2011 was created, because wind energy was not listed in the act at all. In terms of wind data, it is quite lacking. From defective data to missing data, numerous researchers in the past were discredited because they were done near the airport. And because it was near the airport, aircrafts will affect the study at all. Lastly, from the Act, we can see that a renewable energy fund is created. However, it depends on the surcharges from consumers, which means as consumers they just spend less, or if they are poorer, these are negative things towards them. So, what did we find out? Wind speed across Malaysia varies widely from two sources, even three if you consider the one I showed in the introduction. Two different sources with two altitudes showed 6 potential places with the highest speed, Perlis and Kelantan at 100 meters and 10 meters respectively. However, putting these numbers into simulation, we can see that indeed Perlis has the highest power generation. Why negative? I'll go into that later. Using another data set, we can see that Kelantan is again the top. So what went wrong? Why is the data wrong? To be honest, the wind speed across Malaysia means these results are expected. The negative value simply means more power loss than gain. It also means that for typical wind turbine or specification shown earlier, wind energy harvesting is not feasible. Also, two different datasets with wildly different data, we can say it is just height difference, but really it might as well just be incompetent data collection. So how can we have this improvement? For starters, we may consider vertical wind turbine. We may consider putting those turbines onto highways, and we must urge people to collect precise data. To summarize, wind is good and bad at the same time. Malaysia now is in no good state to even think about harvesting wind energy. But given the right tools and motivation, it may become the next big thing. What can we do? Be transparent, be innovative, be educated. Most importantly, be competent. With that, I would like to end my presentation with another quote. We need to keep walking down the right path, and no matter what it takes, we will eventually make progress. Thank you, fellow audience. Now it is your turn. Any questions?